So to sum up then, the architecture of Spark behind the scenes. We have a driver program, we have a cluster manager, we have workers, we have executors. These have all got caches. They've got task threads, maybe more than one, and they're operating and controlled by the scheduler. Particularly, I want to talk about the Spark context. The Spark context is the object we program against. That is the thing which talks to the driver. So we'll be writing our PySpark programs. You must have a value, an object associated with the Spark context. We'll see later on there are a couple of other Spark reserved system variables which all need to be bound. One is called Spark and one is Spark SQL. But the main one that we'll see most of the time is the Spark context. If you look and you find the Spark context does not have a value, then it means you haven't actually generated a relationship with the driver or Spark. So that's just something to watch out for. So that's what's going on underneath the hood. Now when we take a Spark job, I've mentioned this idea of transformations and actions. So here we've got a sample, two sample RDDs, RDD1, RDD2. We've got our usual object kind of syntax, and we're going to join these two together with a group by something or other, which you'll all have met in your database courses, with some filter action. So what happens to this Spark job? Well, the first thing it does is build a graph. A DAG is a directed acyclic graph, which is a graph which goes, a collection of nodes which goes from start to finish without loops. That's why it's acyclic. And it's against this graph that optimizations happen. We could see here we have got multiple objects which need to be transferred between different components. So this is the idea of splitting the graph into stages. This happens underneath the hood. We don't need to know exactly what is happening, but if you have an awareness that it is happening, it allows you to optimize your code later on. As each task gets ready, that's looked after by the cluster manager. That launches tasks via the Spark master, retries failed jobs and so on. In the end, executes tasks and serves and stores returned blocks. So the key part of this code here is this action filter. In the earlier actions like join and group, nothing is actually done, but these elements contribute towards the graph which is optimized. It's not materialized until we get to filter.